Hello everyone, Dennis here. In this video, I'm going to discuss with you GC O-Level Physics October-November 2020 paper 1. Subject code is 6091.
This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard.
Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Alright, now let's start discussing the paper. Question 1. What is the conversion factor for converting megameters to millimeters? A. 10 to the power 3, B. 10 to the power 6, C. 10 to the power 9, or D. 10 to the power 12. The answer is C. 10 to the power 9. Here is the explanation. We know that megameters is 10 to the power 6 meters. Millimeters will be 10 to the power negative 3 meters. To convert from megameters to millimeters, then we can take 10 to the power 6 meters divided by 10 to the power negative 3 meters. Applying indices law, it will be equals to 10 to the power 6 minus negative 3, which is 10 to the power 9. Or, we know that 1 megameters is 1 times 10 to the power 6 meters, and 1 meter is 1 times 10 to the power 3 millimeters. So to convert from 1 megameters to millimeters, it will be 1 times 10 to the power 6 times 10 to the power 3, which gives us 1 times 10 to the power 9 millimeters. Hence, the conversion factor will be 10 to the power 9. Question 2. What row shows the approximate diameter of an atom and the average diameter of the Earth? So here is the table with the first column as the diameter of an atom, second column is the diameter of the Earth. And this is the choices. A. 0.5 micrometers, 12 megameter. B. 0.5 micrometers, 12 gigameters. C. 0.5 nanometers, 12 megameters. Or D. 0.5 nanometers, 12 gigameters. The answer is C. 0.5 nanometers, 12 megameters. And here is the explanation. The diameter of an atom is about 0.1 to 0.5 nanometers. And the diameter of the Earth is 12,742 kilometers or 12,742,000 meters, which is approximately 13 megameters. Therefore, the closest answer will be C, 0.5 nanometers for the diameter of an atom and 12 megameters for the diameter of the Earth. Question 3. A stationary object O is acted upon by 3 forces, as shown in this diagram. What is the value of force X? A. 1 Newton, B. 3 Newtons, C. 9 Newtons, or D. 20 Newtons. The answer is B. 3 Newtons. Here is how we get the answer. The forces in this vector diagram can be rearranged in the tip-to-tail manner, and as you can see here, we can form a right-angled triangle. By applying Pythagoras theorem, phi squared equals to x squared plus 4 squared, then we solve this equation, x squared equals to 5 squared minus 4 squared, x squared equals to 9, then x will be 3 newtons. Question 4. A large metal ball and a small sponge ball are dropped from the top of a high building. They are released at the same time. The metal ball reaches the ground first. Which statement explains this? A. A gravitational field causes heavier objects to accelerate faster than lighter ones. B. The acceleration of free fall g depends on the mass of an object. C. The metal ball reaches a greater speed before the air resistance on it balances its weight. Or D. There is a smaller force of air resistance on lighter objects. The answer is C. The metal ball reaches a greater speed before the air resistance on it balances its weight. So this is the free falling concept. A and B are wrong because the gravitational field does not cause heavier objects to accelerate faster than the lighter ones because it is a constant g equals to 10 meters per second squared. So this also for the option B is also very similar with option A. The acceleration of free fall g does not depend on the mass of an object. Okay, so that's why A and B is wrong. The next one, the D is also wrong. There is a smaller force of air resistance on lighter objects. The magnitude of the force of air resistance depends on the speed of the object. So it does not means that lighter objects has smaller force. Alright, it will depend on the speed. Hence, the only answer which is correct is C. The metal ball reaches a greater speed before the air resistance on it balances its weight. Next question, question 5. The graph shows how the height of a falling object changes with time. Alright, so this is the height time graph, or you can treat it as the displacement time graph. So what is the terminal velocity of the object? A. 1.0 meters per second. B. 1.2 meters per second. C. 1.6 meters per second. Or D. 2.0 meters per second. The answer is D. 2.0 meters per second. So to find the terminal velocity, since as I mentioned just now, this is a displacement time graph, we need to identify where is the terminal velocity, which is this region, because at this region, the graph is a straight line. So when it is a straight line, means that it has constant gradient. So for displacement time graph, gradient means velocity. So it is a constant velocity, means that this is the terminal velocity. So now we just need to find the gradient of this straight line. First, we can identify 2 points with the coordinates that is easy to read. So maybe I will choose this point, which with the coordinates of 1.0 and 3. And I will choose the second point, the last point here, which is 2.50. And now, to calculate the velocity with this formula, displacement over time, this will be the rise, which is 3 meters, and the run with the time, which is 2.5 minus 1.0, we'll get 1.5 seconds. Now we substitute into the formula here, will be 3.0 divided by 1.5, and we'll get 2 meters per second. Question 6. A car is accelerating along a level road. Only the front wheel of the car are driven by the engine. Here are the 4 options. Which diagram shows the direction of frictional force F1 on the front wheels and the direction of frictional force F2 on the rear wheels? The answer is B. To answer this question, you need to understand that frictional force is always opposed or in the opposite direction of the driving force. Hence, for this case, only the front wheel is driven by the engine as stated by the question. So when the engine turns the front wheel, it turns in the clockwise direction. Hence, the driving force is pointing to the left. Therefore, the frictional force will be opposing this force, then it will be pointing to the front. So for the rear wheels, since there is no engine turning the rear wheel, it will just follow the direction of the car or direction of the motion, so it will be pointing to the right. So this is the driving force for the rear wheel. Then I will label this as F. And the frictional force will always be opposing this force, then it will be pointing to the left. Hence, the answer is B. Question 7. Two copper spheres P and Q are at rest on a frictionless surface. The same force F acts on P and on Q for the same time T. The volume of Q is less than that of P. Which quantity is the same for both objects? A. Density. B. Kinetic energy gain. C. Mass. Or D. Weight. The answer is A. Density. The reason is because both the spheres P and Q are made out of the same material, which is copper. So the material will determine the density of an object regardless of whether it is a big size or small size. Alright, so the density will always be the same as long as both spheres are made out of the same material. Now, how about the rest? So the question mentioned that the volume of Q is less than that of P. So now the formula for the density is rho equals to the mass divided by the volume. If I rearrange this equation, the mass m will be equals to rho v. Since rho is a constant, then when the volume decreases, the mass will decrease as well, because both of these two quantities are directly proportional to each other. For kinetic energy, the formula is Ke equals to half mv squared. So since there are different sizes, the mass and the volume will be different, therefore the kinetic energy will be different as well. For weight, we know that the formula is W equals to mg. Since they have different sizes, the volume are different, then the mass will be different, while for the g is constant, which is 10 meters per second square, hence the weight will be different as well. Therefore, for this question, the answer is A, density. Question 8. A metal cube has a mass of 15 grams. Each side measures 4.0 centimeters. The density of the metal is 3.0 grams per centimeters cube. There is empty space in the middle of the cube. What is the volume of the empty space? A. 5.0 centimeters cube. B. 11 centimeters cube. C. 19 centimeters cube. Or D. 59 centimeters cube. The answer is D. 59 centimeters cube. So here is the calculation. We know that the formula of density rho is equals to the mass m divided by the volume v. So we rearrange this formula to make v the subject, hence v will be equals to the mass m divided by the density rho. Then we can calculate the volume of the metal, which is 15 grams divided by the density 3 grams per centimeters cube, and we'll get 5 centimeters cube. The total volume of the whole cube will be 4 cube. Based on the measurements of each side 4 centimeters, hence the volume will be 4 cube, which is 64 centimeters cube. And now the total volume also is equals to the volume of the metal plus with the volume of the empty space. Hence, the volume of the empty space will be the total volume minus the volume of the metal. Then we substitute the value 64 minus 5, which is 59 centimeters cube. Question 9. A man is carrying a load on the end of a light stick. He rests the stick on his shoulder at point P, which acts as a pivot. Then here is the diagram illustrating the condition. He keeps the stick in a balance by exerting a downward force F with his hand as shown. What upward force does his shoulder exert on the stick? A. 60 newtons, B. 24 newtons, C. 40 newtons, or D. 64 newtons. The answer is D. 64 newtons. So based on the principle of moment, the clockwise moment is equal to the anti-clockwise moment. So the F will exert a clockwise moment where the P is a pivot, and the distance of F from the pivot will be 0.3 meters. Hence, the clockwise moment will be 0.3 F. For anti-clockwise moment, 24 newtons will make a anti-clockwise moment, and the perpendicular distance of 24 newtons to the pivot P is 0.5 meters. Hence, anti-clockwise moment will be 24 times 0.5. Then F will be 40 newtons. Now we know that F is 40 newtons. So since this is in equilibrium state, then the total upward force will be equal to the total downward force. So P, the force exerted by the shoulder, will be the upward force. Let's label it as Fp. Hence, Fp will be equal to the total downward force, which is 24 newtons plus the F, which is 40. Hence, it will be 64 newtons. Question 10. Given these four choices, a builder has 4 piles of bricks. Each brick is 0.20 meters long by 0.10 meters wide and 0.10 meters height. Each brick has a weight of 10 newtons. The question is, which pile of bricks produces a pressure of 2000 Pascal on the ground? The answer is A. So we know that to calculate the pressure, it will be F over A, where for this case, the F will be the total weight of for each pile. So to find the total weight of each pile, first we need to know the total bricks for each pile. So for option A, the total bricks will be 32. Alright, so how to get 32? You can look at this direction, right? So we have 2 bricks here. Over here we have 4 bricks, and the height we have 4 bricks. So 2 times 4 times 4 will be 32. Hence we have 32 bricks here. We repeat the same process to calculate the total bricks for option B, option C, and option D. So this is 2 times 3 times 1, 2, 3, 4, 5 times 5. Alright, so 2 times 3 times 5 will get 30. So total bricks for option B is 30. Same thing for C, so this is 3 times 4 times 3, which will get 36. For option D is 3 times 3 times how many here? 1, 2, 3, 4, 5, 6. Right, 3 times 3 times 6 will get 54. Okay, so these are the total bricks for each pile. So now we can calculate the total weight. So 1 brick is 10 newtons. So the total weight for option A will be 32 times 10, which is 320 newtons. So repeat the same process to calculate the total weight for pile B, pile C, and pile D. Then we'll get 30 times 10 is 300 newtons. For C, 36 times 10 will be 360 newtons. And for D is 54 times 10, we'll get 540 newtons. Okay, now the pressure is F over A. We need to calculate the base area, which is in contact with the ground. So now the bottom area for option A, this length, so given that the length of each brick is 0.20 meters, so there are 2 bricks here, then it's 0.4 meters. And then this length, we have 4 bricks, so the width here is 0.10 meters for each brick, so 4 bricks is 0.4 meters. Hence, the bottom area will be 0.4 meters times 0.4 meters, we get 0.16 meters squared. Alright, we repeat the same process for option B, option C, and option D. So option B, this length will be 0.4 meters, this length will be 0.3 meters because we have 3 bricks here and here is 2 bricks. Okay, so then the bottom area is 0.4 times 0.3, which is 0.12 meters squared. For option C, this length will be 0.6 meters, this length will be 0.4 meters. Hence, the bottom area is 0.6 times 0.4, which is 0.24 meters squared. So for option D, this length is 0.6 meters, this length will be 0.3 meters. Hence, the bottom area will be 0.18 meters squared. And now we can calculate the pressure FOA. Now, for option A is 320 divided by 0.16, then we get 2000 Pascal. Option B, 300 divided by 0.12, we'll get 2500 Pascal. Option C, 360 divided by 0.24, we'll get 1500 Pascal. And for option D, 540 divided by 0.18, we'll get 3000 Pascal. So we want to get which pile of bricks produces a pressure of 2000 Pascal. Answer will be A. Next question, question 11. A barometer is set up using a sloping tube as shown. The liquid has a density D and the air has a density ρ. The gravitational field strength is G. Which expression equals the pressure of the air? A. L dg, B. L rho g, C. X dg, or D. X rho g. The answer is A. L dg. Recall that the pressure of liquid formula is P equals to H rho g, where H is the perpendicular height of liquid, rho is the density of liquid, and g is the acceleration of gravity. You might be wondering, we are finding the pressure of the air, so why we need to find the pressure of liquid? So the concept is the pressure of the air will be equals to the pressure of the liquid at the surface of the liquid, which is somewhere in this position. So that's why we can use the pressure of liquid formula to calculate the pressure of the air in the surrounding. Okay, and now you have to be careful with all the symbols used with the and the pressure of liquid formula, the symbol used here. Okay, so H is the perpendicular height of the liquid. Based on the diagram, the L will be the perpendicular height of the liquid. Rho is the density of liquid, so this rho is for density of liquid, but the symbol used for density of liquid is the D, not the rho here. So the symbol rho here is used for the density of the air. So we don't use this symbol. Alright, so G is G, and therefore it should be L dg, not L rho g, or X dg, or X rho g. So answer is A. Question 12. A stone is dropped from rest at the top of a cliff and falls through the air, experiencing air resistance before hitting the sea. As the stone falls, it loses gravitational potential energy P. As the stone hits the sea, its kinetic energy is K. Which statement is correct? A. P is equal to K and the principle of conservation of energy is obeyed. B. P is not equals to K and the principle of conservation of energy is not obeyed. C. P is less than K and the principle of conservation of energy is obeyed because energy is transferred to other forms. Or D. P is greater than K and the principle of conservation of energy is obeyed because energy is transferred to other forms. The answer is D. P is greater than K and the principle of conservation of energy is obeyed because the energy is transferred to other forms. Alright, remember principle of conservation of energy must always be obeyed. Okay, so and the thing is the gravitational potential energy has to be greater than 2k because it has transformed to kinetic energy and also energy loss due to the air resistance. Okay, so that's why the P should be greater than K, and the principle of conservation of energy is obeyed because energy is transferred to other forms. Question 13. A lorry is traveling at a constant speed of 90 km per hour along an expressway. The force on the lorry is 3,600 Newton. What is the work done by this force for each 100 meters traveled? A. 360 joules. B. 14,400 joules. C. 21,600 joules. Or D. 360,000 joules. The answer is D. 360,000 joules. So this question is asking us what is the work done by this force. So based on the work done formula, it will be the applied force times with the distance traveled. So the applied force for this case is 3,600 newtons and the distance is 100 meters. Hence it will be 3,600 times with 100 and we'll get 360,000 joules. Question 14. A force F is used to pull out a box weighing 20 newtons up a smooth incline as shown. The work done by F increases by gravitational potential energy of the box as it rises through a height of 3.0 meters. What is the minimum value of F needed to move the box up the slope? A. 12 newtons, B. 50 newtons, C. 60 newtons, or D. 20 newtons. The answer is A. 12 newtons. So first we need to know what is the distance traveled by the box along the slope. So let's label this distance as x. So since this is a right angle triangle, then we can apply Pythagoras theorem. X squared equals 3 squared plus 4 squared, which gives us 5 meters. Now, assuming that there is no energy loss as this is a smooth incline, hence work done by F will be equals to the gravitational potential energy GPE gained by the box. So work done will be the F times with the distance, same direction with the force, so it's F times 5, and then equals to the GPE will be 20 times 3, as this is mgh, so mg is the weight, and which is 20 newtons, and the height will be 3 meters. Hence the force will be 20 times 3 divided by 5, we'll have 12 newtons. Question 15. Given this diagram, diagram P shows a fixed mass of gas in a container. The piston is raised slowly to increase the volume of the container as shown in diagram Q. The temperature of the gas remains constant. Which statement explains the change in pressure of the gas? A. The particle moves faster, hits the piston more frequently, and the pressure increases. B. The particles move more slowly, hit the piston less frequently, and the pressure decreases. C. The particles move at the same speed, hit the piston less frequently, and the pressure decreases. Or D. The particles move at the same speed, hit the piston more frequently, and the pressure increases. The answer is C. The particles move at the same speed, hit the piston less frequently, and the pressure decreases. So option A is incorrect because the particle will move faster only when we supply energy or the temperature increases. Likewise, option B is incorrect as well because the particles will move more slowly only when they lose kinetic energy or the temperature of the gas decreases. For D, since there are more space as the piston increases, then the particles will hit the piston less frequently. Therefore, the answer will be C. The particles move at the same speed because the temperature of the gas is constant, hit the piston less frequently because there are more spaces in the container once the piston has been raised, and therefore the pressure decreases. Question 16. A gas burner is used to heat water in a glass cooking pot, as shown in this diagram. How does thermal energy from the burner pass through the glass? A. Molecules at the bottom surface of the pot expand and collide with their neighbors, passing on kinetic energy. B. Molecules at the bottom surface of the pot gain kinetic energy and move up to the surface of the glass. C. Molecules at the bottom surface of the pot radiate microwaves which pass through the glass. Or D. Molecules at the bottom surface of the pot vibrate more, passing on kinetic energy to their neighbors. The answer is D. Molecules at the bottom surface of the pot vibrate more, passing on kinetic energy to their neighbors. So this is a process called conduction to transfer the thermal energy from the bottom to the water. So the glass cooking pot is a solid. The molecules will not move, but it will vibrate at its own position. So now, as you can see, for A, the molecules will not expand. Hence, the answer A is wrong. For B, the molecules will not move up, okay, because this is a solid. Hence, molecules have very strong bonds and they won't move freely. For C, it is not by radiation, okay, so over here radiate microwaves, so it means that this is by radiation, but for this thermal transfer, the process is conduction, hence C is wrong as well. So the answer will be D. It will vibrate more when they gain heat, or then the kinetic energy will be more and pass through the energy to their neighbors. Question 17. Which physical property cannot be used to define a scale of temperature? A. The mass of a column of liquid. B. The volume of a glass at a constant pressure. C. The electromotive force produced between junctions of wire of different metals. Or D. The resistance of a metal wire. The answer is A. The mass of a column of liquid. So this question is asking what physical property that can be used to make a thermometer. Alright, the answer is the physical property has to be linear with the change of the temperature. Okay, so the other choices B, C, and D, these quantities can be changed linearly when the temperature change. But for the mass, the definition of mass is the amount of substance of an object. So it will always be fixed even if temperature changes. Question 18. A rectangular swimming pool is 12 meters long, 8.0 meters wide, and it has an average depth of 1.2 meters. A heater increases the temperature of the water from 20 degrees Celsius to 29 degrees Celsius in 24 hours. The density of water is 1000 kilograms per meters cube, and its specific heat capacity is 4.2 joules per gram degree Celsius. No energy is transferred to or from the surroundings. What is the power of the heater? A. 42 kilowatts. B. 50 kilowatts. C. 1200 kilowatts, or D. 3000 kilowatts? The answer is B. 50 kilowatts. So here is the calculation. First, we need to know the volume of the water, which is 12 meters times 8 meters times 1.2 meters. So this is the dimension of the swimming pool, which means it is also the volume of the water. And we'll get 115.2 meters cubed. Next, we know that the formula of density is rho equals to mass m divided by the volume v. So to calculate the mass, it will be rho v. So given that the rho is 1000 and the volume we calculated is 115.2, so multiply these two values together, we'll get 115,200 kg. Next, we need to know how much amount of energy needed to heat the temperature of the water from 20 degrees Celsius to 29 degrees Celsius. So we can use the specific heat capacity formula, Q equals to mc delta T. So the mass is 115,200 kilograms. The C, we have to be careful because it is given that the specific heat capacity is 4.2 joules per gram degree Celsius, but our mass is in kilograms, so we have to convert this into kilograms. Then the C will be 4.2 times 1000, and it becomes 4,200 joules per kilograms degree Celsius. Now we substitute this value into the formula. It becomes times with 4,200 and then multiply with the change of the temperature from 20 degrees to 29 degrees Celsius. Then it's 29 minus 20. Calculate everything. This is the amount of energy needed to heat up the water in a swimming pool from 20 degrees to 29 degrees Celsius, which is 4.35456 times 10 to the power of 9 joules. Alright, now assume there is no energy loss or the water does not absorb heat from the surrounding. Then we can calculate the power. P equals to the Q over the time T. So the Q we calculated from the previous calculation, which is 4.35456 times 10 to the power of 9. And the time given it is 24 hours, so we have to convert it into seconds. Hence it will be 24 times 60 times 60, and we'll get 50.4 kilowatts. So the closest answer will be B, 50 kilowatts. Next, question 19. A sample of warm liquid has a mass of 50 grams. Energy is extracted from the liquid at a steady rate of 200 watts. A student records the temperature of the sample at regular time intervals. The graph shows her results. What is the specific latent heat of fusion of the sample? A. 0.040 joules per gram. B. 8.0 joules per gram. C. 60 joules per gram. Or D. 400 joules per gram. The answer is D, 400 joules per gram. So the question asks us to find the specific latent heat of fusion. So this only happens when the matter changes from liquid to solid, which is during the freezing process. So on the graph, this region is the freezing process because the temperature is constant even though it is being cooled down. Okay, so now here's the calculation. First, we calculate the energy. Energy equals to the power times the time. So the power is 200 and the time from the graph is from 50 seconds to 150 seconds. Hence, it will be 150 minus 50. And we calculate, it will become 20,000 joules. Next, to find the specific latent heat, it will be energy divided by the mass. So it will be 20,000 joules per 50 grams, and we'll get 400 joules per gram. Question 20. A 2.0 gram block of aluminium needs 36 joules of thermal energy to increase its temperature from -10 degrees Celsius to 10 degrees Celsius. What is the numerical value of the ratio specific heat capacity of aluminium over heat capacity of the block? Is answer A 1 over 30, or B 1 over 10, C 1 over 2, or D 2 over 1? The answer is C 1 over 2. So here's the calculation. We need to find the ratio of specific heat capacity of aluminium over heat capacity of the block. So what we need to do is we just substitute the formula for specific heat capacity of aluminium. It will be Q over M delta T, and the formula for heat capacity of the block will be Q over delta T. So the next thing we need to do is we need to simplify this ratio. Everything is just mathematics. So we can rewrite this ratio to be Q over M delta T divided by Q over delta T. Next step, we change the division to multiplication. Hence, the Q over delta T become reciprocal, and it will be delta T over Q. Now we cancel the Q with the Q and the delta T with the delta T. So it can be simplified to become 1 over M. Given that the mass is 2.0 grams, hence the answer will be 1 over 2. Question 21. Which row gives an example of a longitudinal wave and of a transverse wave? So here are the choices. The first column is longitudinal wave and the second column is transverse wave. The choices are A. Light, ultrasound, B. Microwaves, radio waves, C. Radio waves, microwaves, and D. Ultrasound, light. The answer is D. Ultrasound. Okay, so from all these choices here, only ultrasound is longitudinal wave. The rest are transverse wave. Hence, the answer is D. Ultrasound as longitudinal wave and light as transverse wave. Question 22. The diagram shows part of a long stretched spring. A longitudinal wave is traveling along the spring. A point on the spring moves backwards and forwards between two positions that are 1.0 centimeters apart. Which row describes the wave? So here are the choices. The first column is amplitude in cm. The second column is wavelength in cm. So choice A, 0.50, 12. B, 0.50, 24. C, 1.0, 12. Or D, 1.0, 24. The answer is A, 0.50 cm for amplitude and 12 cm for the wavelength. Alright, so now how we get the amplitude, which is 0.50 cm? So the question says that a point on the spring moves backwards and then move forwards. The distance between these two positions is 1.0 cm. Hence, this is 0.5 cm and this distance is 0.5 cm. So this distance is the amplitude. Therefore, answer is 0.50 cm for the amplitude. Now, how to determine the wavelength? The wavelength can be measured between two successive compressions. So for this case, it is this region and the wavelength is 12 centimeters. Therefore, answer is A. Question 23. A wave travels at a speed of 1.4 kilometers per second and has a wavelength of 0.70 mm. What is the frequency of the wave? A. 0.98 Hz, B. 2.0 Hz, C. 2.0 times 10 to the power 3 Hz, or D, 2.0 times 10 to the power 6 Hz. The answer is D, 2.0 times 10 to the power 6 Hz. So here's the calculation. We'll use the waveform formula V equals to F lambda. And to find the frequency, F will be equals to V over lambda, where V is the speed of the wave and lambda is the wavelength. So for this case, given that it is 1.4 kilometers per second, we write it in meters per second, hence it will be 1400, and the wavelength is 0.70 millimeters. So it will be divided by 0.7 times 10 to the power of negative 3. When we calculate, we'll get 2 times 10 to the power 6 Hz. Therefore, the answer is D. Question 24. The diagram shows a thin converging lens forming a real image of an illuminated object. What happens as the object is moved towards the focal point F? A. The image moves further away from the lens and decreases in size. B. The image moves further away from the lens and increases in size. C. The image moves towards the lens and decreases the size. Or D. The image moves towards the lens and increases the size. The answer is B. The image moves further away from the lens and increases in size. So to get the answer, we can draw a new object which is, as described from the question, move towards the focal point. So this object is closer to the focal point compared to the original object. Okay, next we complete the ray diagram. First we draw a horizontal line or horizontal ray which is parallel with this horizontal line. Okay, as you can see, this ray is same as this ray, then it will follow the same path. So you bend and then cross the focal point and another side, and then continue to move in a straight line. And next, the second ray will be from this tip of the arrow, then pass through the center of the converging lens and continue to move straight. So these two rays will meet at one point, and this point can form the new image. As you can compare this new image with the original image, so this image is further away from the converging lens and the size is bigger than the original image. Hence, the answer is B. The image moves further away from the lens and increases in size. Question 25. Light is shown onto a transparent plastic block in the air, as shown in the diagram. The light enters the block at X. At Y, most of the light is reflected, but some emerges into the air along the surface of the block. Which diagram shows the angle of refraction R at X and the critical angle C at Y? So this is option A, option B, option C, or option D. The answer is C. Now recall that angle of refraction is the angle between a refracted ray and the normal. So if you look at the diagram C, this is the normal and this is the refracted ray. So the angle between the refracted ray and the normal will be the angle of refraction. Next, critical angle is when the angle of reflection is exactly 90 degrees, the angle of incidence is called the critical angle C. So this is the definition of critical angle. So as you can see from the diagram, when this refracted ray is 90 degrees, so this incident angle will be the critical angle. Hence, the answer is C. Question 26. Which does not involve an echo of an ultrasound signal? A. Bats detecting obstacles in their path. B. Satellites detecting objects moving towards them in space. C. Fishing boats measuring the depth of the sea. D. Doctors producing the image of an unborn baby. The answer is B. Satellites detecting objects moving towards them in space. So why the option B does not involve an echo of an ultrasound signal? So here's the reason. Recall that ultrasound wave is longitudinal wave that cannot travel through vacuum or space. So the keyword here is space. So ultrasound cannot travel through vacuum, hence option B is the answer. Question 27. The wave diagram represents a sound wave. The sound is then changed so that it is louder and at a lower pitch. Which diagram represents the new sound? This is option A, option B, option C, or option D. The answer is C. So the new sound has to be louder, which means that it has larger amplitude compared to the original sound wave. Also, it has to be at a lower pitch, which means that it has lower frequency or larger period. So as you can see from option A, from option C, it has larger amplitude. So this is how we measure amplitude. So this distance is larger than the original distance here. And for lower frequency or larger periods, as you can see, this complete cycle takes longer time compared to the original sound. It takes less time to complete one full cycle. Hence, the answer is C. Question 28. A negatively charged polyethylene rod is near to an Earth metal sphere. Which diagram shows the distribution of charge on the sphere? This is option A, option B, option C, or option D. The answer is A. We know that light charges repel. So when the negatively charged polyethylene rod is near to the metasphere, the negative charges of the metasphere, which is near to the rod, will be repelled to another end of the sphere. And since this sphere is Earth, this repelled negatively charged will be flowing to the Earth and neutralized. Hence, only left with the positive charges, which is close to the negatively charged polyethylene rods. Hence, the answer is A. Question 29. There is a current of 0.32 amps in a wire as shown. The charge of an electron is 1.6 times 10 to the power negative 19 coulomb. What is the rate of flow of electrons along the wire and in which direction do they move? A. 2.0 times 10 to the power 18 per second from the left to right. B. 2.0 times 10 to the power 18 per second from right to left. C. 5.0 times 10 to the power negative 19 per second from left to right. Or D. 5.0 times 10 to the power negative 19 per second from right to left. The answer is B. 2.0 times 10 to the power 18 per second from right to left. So here's the calculation to get the rate of flow of electrons. We let n to be the number of electrons flowing in the wire. So the current definition will be the rate of flow of the charges or we can use this formula, total charges divided by total time. So put them into a formula, I equals to Q over T. Now we substitute the values given, so the current is 0.32 and the charge is 1.6 times 10 to the power negative 19 per electron, and we need to multiply by n because n is the number of electrons flowing in the wire, so we'll get the total charges and then divided by T. So what we need to calculate is the rate of flow of electrons, hence it will be n over T. So n over T will be equals to 0.32 over 1.6 times 10 to the power negative 19, and we calculate, we'll get 2.0 times 10 to the power 18 electrons per second. Now the next question, in which direction do they move? So the current direction shown in the diagram here is the conventional current flow. So the flow of electrons will be in the opposite direction, hence it will flow from right to left. So answer is B. Question 13. A student has 6 cells, each of EMF 1.5 volts. Which combination of cells give a total EMF of 6.0 volts? So option A, option B, option C, or option D. The answer is C. So how to calculate the combination of cells that give a total EMF of 6.0? So we have to determine the direction of the terminals of each cell. So each cell represents 1.5 volts, and the longer line means it's positive terminal, the shorter line means the negative terminal. So this is how we label each cell for option A. So the first cell is plus 1.5 volts minus, right, means that the right hand side is the positive terminal and the left hand side is the negative terminal. So same as this, but this is opposite because this line is shorter than this line. So that means this negative terminal, then this positive terminal. So it'll be minus 1.5 volt plus here. So this one again is plus 1.5 volt minus. This is also positive 1.5 volt minus, but this short line is negative 1.5 volt minus. Minus 1.5 volt plus. Okay, now we calculate the total EMF. If it start with positive, that means you add. If it is start with negative, then we minus. So we have 1.5 volts. We have how many? 1, 2, 3, 4. 4 cells arranged in the same direction, and then we minus 1.5 is the opposite direction. How many do we have? We have 2 cells connected in the opposite direction, hence we minus 1.5 times 2. Then we calculate everything, we get 3.0 volts. So repeat the same process for the other options and see which ones give us the total EMF of 6.0 volts. So for option B, again split it into each cell, and this is the voltage direction for each cell. So this positive 1.5 volt minus 1.5 volt positive, and all the way to the last one. And we do the same thing, calculate the total EMF. So we have 2 cells connected in positive 1.5 volt negative direction, hence this 1.5 times 2. And then we have the rest of the cells are connected in the opposite direction, which have 4 cells, so it's minus 1.5 times 4. And we calculate, we get negative 3.0 volts. So this is not the answer that we want 6.0 volts. Alright, now C, do the same thing. Each cell, this is positive 1.5 volt minus, positive 1.5 volt minus, and so on. Alright, so now we calculate the total EMF. So the cell with positive 1.5 volts negative will be 1, 2, 3, 4, 5. We have 5 cells arranged in this manner, so it times 5. And then only one cell is arranged in the opposite direction, hence we minus 1.5, and we'll get 6.0 volts. Okay, so this is the answer that we want. So answer will be C. Of course, let's practice for the D. Again, So go and determine where is the direction of the terminals for each cell. So this is positive 1.5 volt minus all the way to the last one, negative 1.5 volt positive. Alright, so the total EMF arranged in positive direction will be how many? 1, 2, 3. So times 3. In the opposite direction, we have 1, 2, 3 as well. So we times minus 1.5 times 3. And the total EMF will be 0 volts. And this is not the answer that we want. Therefore, there is only one answer, option C. Question 31. When a charge of 15 coulomb passes through a resistor in 10 seconds, the work done is 60 joules. What is the current in the resistor and what is the potential difference PD across it? So here are the choices. The first column is current in ampere, second column is PD in volts. So option A, 1.5, 0.25. Option B, 1.5, 4.0. Option C, 150, 0.25. Or option D, 150, 4.0. The answer is B, 1.5 amps for current and 4.0 volts for PD. So here is the calculation. We know that the formula for current I equals to Q over T. So the charge is 15 coulomb and the time is 10 seconds. Hence it will be 15 divided by 10, which is 1.5 ampere. Then to calculate the PD, it will be the work done divided by the charges. So the work done given is 60 joules and the charge is 15 coulomb. Hence the PD will be 60 divided by 15, which gives us 4 volts. Therefore the answer is B, 1.5 amps for the current and 4.0 volts for the PD. Question 32. The circuit shown consists of a battery, 3 resistors and 2 ammeters. What are the resistances of resistors X and Y? So here are the options. For the first column, it is resistance of X in ohms, and second column, resistance of Y in ohms. Option A, 3.0, 3.0. Option B, 3.0, 6.0. Option C, 6.0, 3.0. Or option D, 6.0, 6.0. The answer is C, 6.0 ohms for resistance of X and 3.0 ohms for resistance of Y. So here's the calculation. First, we need to get the current at this branch. So the reading for the first ammeter is 4.0 amps, which is the current that flows up from the battery, and this is the total current. Next, this is the current for the second branch, and the reading is 2.0 amps. So this is I2, the current of the second branch. So let's label the current for the first branch as I1. So the relationship between the total current I1 and I2 will be IT equals to I1 plus I2. So I want to find current number 1, it will be IT divided IT minus I1, IT minus I2. So it will be 4.0 minus 2.0, which gives us 2.0 amps. Next, to get the resistance of resistor X, we'll use the Ohm's law, V equals to IR, hence Rx will be V over I1. So substitute the values. So since the resistor X is connected parallel with the cell, 12 volts, hence its voltage also 12 volts. So 12 divided by 2, we get 6 ohms. Next, before we want to calculate the resistance of the resistor Y, first we need to determine the voltage of 3.0 ohms. Let's label it as V3. So applying the Ohm's law, V3 equals to I2 times R3. Substitute the values. I2 is 2 amps and the R3 is 3 ohms, so we get 6 volts. And now we want to determine the voltage across the resistor resistor Y. Let's label as Vy. So to get the Vy, it will be the total voltage Vt minus V3. Okay, the reason is because the 3 ohms resistor is connected series with resistor Y, and they are connected parallel with the battery, which is 12 volts. Hence, their total voltage V3 plus Vy will be equals to 12 volts. Hence, to get Vy will be equals to Vt minus V3, which is 12 minus 6, and we get 6 volts. Now, to calculate the resistance of resistor Y, Ry, then applies the Ohm's law, V equals to IR. Hence, Ry will be Vy over I2. So, Vy is 6 volts, I2 is 2 amps, so 6 divided by 2 will get 3 ohms. Hence, the answer is C, 6.0 ohms for resistance of X and 3.0 ohms for resistance of Y. Question 33. The diagram shows a potential divider circuit with a fixed resistor of resistance 2.0 kilo ohms and a thermistor. At room temperature, the resistance of the thermistor is 6.0 kilo ohms and the potential difference PD across the fixed resistor is 1.8 volts. The circuit switches a fan when the resistance of the thermistor decreases to 2.0 kilo ohms. What is the PD across the fixed resistor at this point? A. 1.2 volts, B. 2.4 volts, C. 3.6 volts, or D. 7.2 volts. The answer is C. 3.6 volts. So here's the calculation. Now the first thing we need to do is we need to determine what is the input voltage. Alright, so before we want to determine the input voltage, we need to do some calculations. So given that the potential difference across the fixed resistor is 1.8 volts. So let's label 1.8 volts on the diagram. And now we need to calculate the current that flows into the circuit. So the current here, by applying the Ohm's law, V equals to IR. So the I here will be the PD across the fixed resistor divided by the resistance of the fixed resistor. So it will be 1.8 divided by 2 kilo ohms, and we'll get 0.9 milliamps. So given that the resistance of the thermistor is 6.0 kilo ohms, so let's label the resistance of the resistor as 6 kilo ohms. And now we need to determine the PD across the thermistor. So let's label in the diagram is VTH. So to calculate VTH, we apply Ohm's law again, which is I times the R. So the current is 0.9 milliamps, then the resistance is 6 kilo ohms, and we'll get 5.4 volts. And now we can determine the input voltage Vin. So the Vin will be the sum of the PD across the fixed resistor and the thermistor. So it will be 1.8 plus 5.4, and we get 7.2 volts. Next, when the resistance of the thermistor decreases to 2.0 kilo ohms, the circuit switch on the fan. So now we change the resistance of the thermistor from 6 kilo ohms to 2 kilo ohms. Now the PD across the thermistor will change since the resistance change. So we can apply the potential potentiometer formula, R2 over R1 plus R2 times Vin. Now the R2 is 2.0 kilo ohms, the R1 is 2.0 kilo ohms as well. So then substitute the values inside. 2.0 kilo ohms divided by 2.0 kilo ohms plus 2.0 kilo ohms times with the Vin 7.2. If we calculate, we get 3.6 volts. Hence, the answer is C, 3.6 volts. Question 34. What is the purpose of a fuse in a circuit and where is it wired? So here are the options. A. The purpose is to protect the wires from overheating and it is wired in the earth wire. B. The purpose of a fuse is to protect the wires from overheating and it is wired in the live wire. C. The purpose of a fuse is to protect the user from electric shock and it is wired in the earth wire. Or D. The purpose is to protect the user from electric shock and it is wired in the live wire. The answer is B. To protect the wires from overheating and it is wired in the live wire. So recall the function of a fuse, which is to protect the electric circuit from damage caused by overcurrent. If the current exceeds a specific threshold, the fuse will blow or melt, breaking the circuit and stopping the flow of electricity, thus preventing damage to the components of fire hazards. Okay, so this is the function of a fuse as defined by the textbook. So over here is to prevent fire hazards. Therefore, answer will be B. The purpose is to protect the wires from overheating and thus prevent from fire hazards. And of course, it has to be wired in the live wire because the live wire is the wire that carries the current. Okay, to protect the user from electric shock, usually this is the purpose when we want to earth an electrical appliance. Okay, so and that's why the function of the earth wire. Question 35. Which statement about magnets is correct? A. Permanent magnets are made of pure iron. B. Magnets sometimes have an north pole without an south pole. C. The north pole of a magnet points towards the Earth's geographic north pole. Or D. There is a force of attraction between two south poles. The answer is C. The north pole of a magnet points towards the Earth's geographic north pole. So here's the explanation. The Earth's geographic north pole is actually near the Earth's magnetic south pole, which is why a magnet's end pole is attracted to it. Now, why is option A is wrong? Because permanent magnets are not made of pure irons. For B, magnets must have both north pole and south pole, so it cannot be without a south pole. And for option D, it is not the force of attraction between two south poles. So remember, like poles will repel, so it should be the force of repulsion. Question 36. Which action is used to demagnetize a magnet? A. Connect the magnet to a circuit so that there is a direct current in the magnet. B. Connect the magnet to a circuit so that there is an alternating current in the magnet. C. Place the magnet inside a coil in which there is an alternating current and then slowly remove the magnet. D. Place the magnet inside a coil in which there is a direct current and then slowly remove the magnet. The answer is C. Place the magnet inside a coil in which there is an alternating current and then slowly remove the magnet. Okay, so now for option A and option D are incorrect because we can't use direct current to demagnetize a magnet. Okay, option B, it is not enough just to supply an alternating current. Okay, we need to slowly remove the magnets from the coil, then we can demagnetize the magnets. Alright, so that's why option B is incorrect. Question 37. Given this diagram, wire XY carrying a current is placed at right angles to the magnetic field between two magnetic poles. In which direction does the force on the wire act? Alright, the answer is B. To determine the direction of the force, we need to use Fleming's left hand rule. So use your left hand. Now your index finger is pointing the direction of the magnetic field from North Pole to South Pole in this manner. Then your middle finger is pointing the direction of the current flow. So it will point at this direction. Now your thumb will automatically pointing upwards, which points the direction of the force that the wire acts. Hence, the answer is B, pointing upwards. Question 38. Given this diagram, the diagram shows the waveform seen on the screen of a cathode ray oscilloscope when an AC generator is connected to it. What happens to the waveform when the speed of rotation of the generator is half? So here are a few options. Option A, amplitude is doubled, distance x is the same. Option B, amplitude is half, distance x is half. Option C, amplitude is half, distance x is doubled. Or option D, amplitude is the same, distance x is doubled. So the answer is C, amplitude is half and distance x is doubled. So here's the explanation. When speed is half, the rate of change of magnetic flux is half. Hence, the amplitude is half because the waveform shown in the oscilloscope is the voltage generated by this AC generator. Okay, so since rate of change of magnetic flux is half, then the voltage generated will be half as well. Therefore, amplitude is half. Now, how about the frequency? So the frequency will be half because based on the formula, V equals to F lambda. V is the speed. When speed is half, the frequency will be half as well. Alright, so they are directly proportional to each other. And the period is doubled. The reason is because period T equals to 1 over F. Okay, so when the speed is half, the frequency is half as mentioned here, then the period will be doubled. So when period is doubled, x is doubled because x represents the period of the waveform. Hence, the answer we see, amplitude will be half and the distance x is doubled. Question 39. Light shines into the open end of a box, as shown in this diagram. Two LEDs emerging from the box are connected to a sensitive ammeter which reads 0. A bar magnet is moved towards the open end of the box and the needle of the ammeter deflects. When the bar magnet stops moving, the needle turns to 0. What is connected to the two LEDs inside the box? A coil connected in series with a cell. B, a coil only. C, a light-dependent resistor LDR in series with a cell. Or D, a light-dependent resistor LDR only. The answer is B, a coil only. So based on Faraday's law, when a bar magnet is pushed into a coil, a change of magnetic flux linkage happens. An induced current is generated and flows through the coil, and this causes the needle of the ammeter to deflect. hence the answer is B, a coil only. And finally, the last question, question 40. A varying potential difference PD is connected across a 50 ohms resistor and a cathode ray oscilloscope CRO. The diagram shows the waveform seen on the screen of the CRO. The Y gain is set at 10 volts per division and the time base is set at 0.25 milliseconds per division. What is the energy dissipated in the resistor in one period of the waveform? A. 0 millijoules, B. 2.0 millijoules, C. 4.0 millijoules, or D. 8.0 millijoules. The answer is C. 4.0 millijoules. So here is the explanation. First, we need to determine the amplitude of the wave. So for this case, amplitude has two divisions. So based on the setting, the Y gain is 10 volts per division. Hence, the 2 division times the 10 volts, we get 20 volts. So the 20 volt, the amplitude for this wave is 20 volts, which tells us that the maximum voltage is 20 volts. Next, we look at the period of this wave. So from the diagram, the period has two divisions and the setting is 0.25 milliseconds per division. Therefore, it will be 2 division times 0.25 milliseconds. Hence, the period is 0.5 milliseconds. Now, to calculate the power dissipated, it will be V squared over R. So, the voltage is 20 and the resistance is 50 ohms. So, the power dissipated will be 20 squared over 50. We'll get 8 watts. Now, to calculate the energy dissipated, it will be power dissipated times with the period, which is 8 watts times 0.5 milliseconds, and we'll get 4.0 millijoules. Hence, the answer is C, 4.0 millivolts. Alright, that's the end of the paper, and that's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Support me. If my videos benefit you in your learning, you can treat me a cup of coffee. To do this, link is at the description area. Until then, see you in the next video. Have a great day ahead and all the best.